In this video, we're going to talk about simplifying rational expressions. Our goal is going to be to take a rational expression and factor out any common factors or variables from the top and bottom of our rational expressions to put it into a simpler or even a possibly nicer form. So let's start with a very easy example. We've got 3x to the 7th divided by 2x to the 4th. And I want to simplify this. I want to see, can I change this into a different form that would be equivalent, but maybe the numbers are a little bit nicer to work with, or maybe the variables have smaller powers. So, first thing we're going to do is look at the coefficients, 3 and 2. And I'm going to take them off to the side here, 3 over 2, and ask yourself, can you simplify this fraction? Is there any number you can divide the top number by to get a whole number, and also divide the bottom number by that same number and get a whole number? Well, it turns out with 3 over 2, it's already in simplified form, so I cannot simplify this any further than it already is. So we know our answer is going to include 3 over 2. Now we look at the variables. Most importantly, do we have the same letter for our variable? And yes, we do. They both are x's. One is x to the 7th, the other is x to the 4th. And if we think back to our Algebra 1 days, we remember that, oh, when I have the same variable in a fraction, there is the quotient of powers property, which says I can take the top and subtract the bottom exponent. So really, x to the 7th over x to the 4th is going to turn out to be the same thing as x to the 7 minus 4. Okay, because we can subtract with that quotient of powers property. And this is all going to turn out to be 3x to the 3rd over 2. This is the exact same value. If we put something in for x, we're going to get the exact same value here as we would have over here. And all we had to do was see if we could simplify the coefficients, which we couldn't, and then handle the exponents on the variables. Same variable, x over x, and then we can subtract them, 7 minus 4, which gave us 3. It's important to note, why did we put the x to the 3rd on top instead of below? Because the higher exponent was on top. So if the higher exponent's on top, when you do your subtraction, it's going to stay on top. If the higher exponent is on the bottom, when you do your subtraction, it will stay on the bottom. Let's try another one like this. Here we have 16x to the 4th over 8x to the 9th. Just like before, let's take a look at our coefficients first, and I'm going to write them over here. I've got 16 over 8, or 16 divided by 8. Now, can we simplify that at all? Well, it turns out, yes, we can. Both of them are divisible by 8. 8 divided by 16 is 2, 8 divided by 8 is 1, so we get 2 over 1, which is just 2. So we have now simplified the 16 over 8. It is 2. Now let's look at our variables. Do they have the same letter? Yes, they do. So, just like before, we've got them in a fraction setup. We've got x to the 4th over x to the 9th. So we are going to do our subtraction with our quotient of powers property again. This would be x to the 4th minus 9. And you know what, I should write it over here, so x to the 4th minus 9. And what's that going to become? That's going to become 2 over x to the 5th. 4 minus 9, let's look at this closer just to make sure. 4 minus 9 is a negative 5, so we actually have x to the negative 5. And what do we do with negative exponents? We move them into the denominator to make them positive. So if I have 2 times x to the negative 5, it's going to be the same thing as 2 over x to the 5th. And there is our answer, 2 over x to the 5th. Also, notice that I said with the first example, when the higher power is on top, it stays on top in our answer. And when our higher power is on the bottom, it stays on the bottom in our answer. So that still came true with this. All right, now let's try another type, because these are just monomials. What if we have binomials or trinomials that we're trying to simplify? Let's take a look. So here we have two trinomials, two quadratic trinomials, x squared minus 2x minus 3 over x squared plus 5x plus 4. And our goal is to simplify this. And you might be thinking, oh, I've got an x squared in the front here and an x squared in the front there. I can just cancel them out. Do not do that. That is incorrect. You cannot cancel like that when you are adding or subtracting pieces. You can only cancel top and bottom like that when you are multiplying or dividing. So we need to come up with a way to simplify this if it's possible. And the way we're going to do this is to factor the top. We're going to use the diamond method in our factoring methods to factor the top and factor the bottom. And look at their factors. What two binomials make up each of our trinomials? And if they share any binomials, we can cancel those out. So let's take a look at the very top. We're going to use our diamond method. So I've got A equals 1, B equals negative 2, and C equals negative 3. Up top is A times C, so I've got negative 3. Down below, I have B, so it's negative 2. And now I have to find two numbers that multiply to negative 3, but add to a negative 2. And that turns out to be negative 3 times 1. Because negative 3 times 1 is negative 3, and negative 3 plus 1 is a negative 2. We divide by A if A is not 1. So since A is 1, we don't have to divide by it. These are pieces of our factors, and what this turns out to be is x squared minus 2x minus 3 is the same thing as x minus 3 times x plus 1. There are the factors that multiply out to this trinomial. Now we're going to do the exact same thing to the bottom. So for the bottom, A is 1, B is 5, C is 4. Okay, A times C up top, that's 4. B below is 5. And I need two numbers that multiply to 4 but add to 5. Well, that would be 1 and 4. Once again, if A was not 1, we would have to divide by A and do a different step. But since A is 1, we don't have to. So 1 times 4 is 4. 1 plus 4 is 5. Our factors for the bottom are x plus 1 times x plus 4. And as I'm erasing this, I want you to take a look at those factors, and are there any factors the same from top and bottom? And hopefully you notice that, yeah, they both have x plus 1 on the top and the bottom. They share that factor. Well, since they share that factor can divide itself out. And we're left with our final answer of x minus 3 over x plus 4. There's our final answer. We have now successfully simplified. If I put a value in for x here, work out the problem, it's going to be the exact same thing as if I put that value of x in to this, which is kind of nice. All right, we're going to do one more example that's very similar, and then that's going to be it for this video. Actually, before we take a look at that last example, let's look at this one last time. Because I have x's in the denominator, we have an issue of possibly creating 0 in the denominator. Is there any values of x that are going to make this equal to 0? And we look at the factors to figure that out. If I put a -1 into this factor, it would become 0, which would then multiply by this and be 0. So we have to say that this is our simplified answer, x minus 3 over x plus 4. But we also have to say that x cannot equal -1. Even though that factor cancels out, this is a simplified version of this original, so we have to include what is going to break the function in our answer. So x cannot equal -1, and what about here? What can x not be here? Right, it can't be a -4. So x cannot equal -1 or -4. With that very first example we have, which I don't have up anymore, x could not be 0 because, well, 0 was going to be the only thing on the denominator. Alright, now let's take a look at one last example. Alright, here we go. We have a binomial, 3x plus 4, over a trinomial, 3x squared plus x minus 4. Our goal, once again, is to factor out anything from the top and from the bottom, see if they share any factors, and cancel those out. So don't think, oh, they both start with a 3 and both end with a 4. I can just cancel those out right away. No, you cannot. No, you cannot. So let's take a look at the top first. 3x plus 4. They both don't have variables, so I can't factor anything out that way. And 3 and 4 only have a 1 in common. So the greatest common factor between our 3x and our 4 is 1. So we can't do anything to the top. So 3x plus 4 is going to stay on the top. Now we got to focus on the bottom. We're going to do our diamond method down here, and notice that a is not 1 this time, so we're going to have to do the full diamond method with all the steps. But don't worry, I'll walk you through it. So a is 3, b is 1, and c is a -4. Alright, a times c up top is 12, b is 1. I need two numbers that will multiply to 12 and add to, sorry, this should have been a -12 up top, my bad. So I need two numbers that multiply to a -12 and add to a +1. So let's think about it. 1 times 12, we'll worry about the negatives in the end. 2 times 6, and 3 times 4. All of those will multiply to 12. If I make one of them in each pair negative, we'll get our negative. But which one, if you add them together, is going to get us 1? And hopefully you say -3 and 4. That is correct. So we've got 4 and -3. Doesn't matter what side you put them on. Those two multiplied together will give us -12. Added together will give us 1. Now, a was 3. So I have to divide both sides by 3 if I want this to work out correctly. -3 divided by 3, that's a -1. That simplifies down, meaning we're going to have a factor of x minus 1. 4 over 3. We can't simplify that. There's nothing we can do to this. So what happens is the denominator becomes your coefficient on the variable, and then we add the numerator because it's positive. So this is going to be 3x plus 4, where we took the denominator, it moved next to the x, it becomes the coefficient, and then the 4 becomes the constant. And now we've done the diamond method and gotten the factors of our denominator. And look at what we have. 3x plus 4 over 3x plus 4 times x minus 1. Well, look at the 3x plus 4s. I've got one on the top and one on the bottom. So they will cancel. And when we cancel out everything on the top, it's just going to leave us a 1 on the top and an x minus 1 on the bottom. This is our simplified rational expression. There we go. We have successfully simplified this rational expression. Now we just got to worry about when is this function undefined? When is the original denominator equal to 0? And that comes from the diamond method, what we just did here. It is the opposites of the numbers we ended up with on the side. So x cannot equal the negative 4/3 or a positive 1. If any of those were put in, we would be undefined. So, what did we do? Couldn't do anything with the top, so the top stayed the same. We did the diamond method on the bottom. We factored it out, which gave us common factors, top and bottoms, which could be crossed out since they're dividing each other and becoming 1. So we get 1 over the factor that was left, x minus 1. Then we looked at our factors, or the factors from the diamond method, changed their signs to the opposite, and said, oh, x cannot be those values because that will make it 0 on the denominator, which is undefined. And there we go. We have successfully simplified rational expressions. Hopefully you found this video useful, and good luck.